Here we have a problem of the week 8, and the problem says, a driver travels northbound on a highway at a speed of 25.0 meters per second. A police car traveling southbound at a speed of 40 meters per second approaches with its siren producing sound at 2500 Hz. A. What frequency does the driver observe as the police car approaches? B. What frequency does the driver detect after the police car passes him? Repeat parts A and B for the case when the police car is traveling northbound, that is the case C. So, we have the velocity, the speed of the driver, that is this one, the speed of the police, the frequency of the police, of the siren of course, and the speed of sound, that is 343 meters per second. And in case A, we have here's the driver going northbound, the police going southbound. So the driver is approaching to the police, and the police is approaching to the driver, right? So the frequency that the driver hears is the frequency 0, that is the frequency of the police, the siren police, times the velocity, the speed of sound, less the speed of the driver, between the speed of sound less the speed of the police. That's why the driver is approaching to the police and the police is approaching to the driver. So here we have the data, and here we have the 2500 Hz per 343 plus 25 between 343 minus 40, and we obtain this frequency. So that result is okay because the frequency is going to hear louder, and the frequency is 3036.363 Hz. Then for the case B, after the police passes the driver, here we have the formula. That is that the frequency the driver is going to listen is the frequency 0, that is the police frequency. Then that frequency times the speed of sound less the speed of the driver because it's getting away from the police, between the speed of sound plus the speed of the police that is getting away from the driver. And here we have this equation in terms of all the speeds and frequencies, and it's 2500 times 343 minus 25 between 343 plus 40, and here we have the frequency that the driver listens, and it's 2055.72 Hz. For the case C, it says that the police is approaching to the driver in the same direction, that is northbound. So in case B, here we have that the frequency that drivers listen is the frequency of the police, that is this one, times the speed of sound, that is this, minus the speed of the driver, that is getting away from the police, between the speed of sound, that is this one, minus the speed of police that is approaching to the driver. And here we have that the driver listens this frequency, that is 2623.76 Hz. And C, case B, here we have that the frequency that the driver listens is the frequency of the police, that is this one, times the speed of sound plus the speed of driver because it's getting... in case B, the police already passed the driver. So here is plus because the driver is approaching to the police. So that between this, that is the speed of sound plus the speed of police, and here we obtain that the frequency that the driver listens is 2402.088 Hertz.